Assalamu alaikum and welcome to Cambridge Chemistry channel with SarwatAhmed. Be sure to like the video and subscribe. It really helps the channel to grow. In this video I will discuss question number 3, qualitative analysis of paper 3 9701. Qualitative analysis where reagents are selected for use in a test. The name or correct formula of the element or compound must be given. At each stage of any test, you are record details of the following. Color change is seen, the formation of any precipitate and its solubility in excess of reagent added, the formation of any gas and its identification by a suitable test. You should indicate clearly at what stage in a test changes occur. If any solution is warmed, a boiling tube must be used. Rinse and reuse test tubes and boiling tubes wherever possible. No additional tests for ions present should be attempted. Question number 3, FB5 is a salt containing one cation and one anion, both of which are listed in the qualitative analysis notes. Place a small spatula, measure FB5 into a hard glass test tube and heat the tube gently at first and then more strongly. Record all your observations. Solid condenses. When I heated this FB5, I have seen solid condenses, pungent smell is observed, water vapors on the side of test tube were present, and all the solid disappears when heating more strongly. Place the remaining FB5 into a 100 centimeter cube. If pungent smell is observed, then I have tested with the red litmus paper. So gas evolved turns turns damp red litmus paper blue. It means this contains ammonium ions which produces pungent smell and which turns damp red litmus paper blue. When I placed damp red litmus paper on the test tube, place the remaining FB5 into 100 centimeter cube beaker and add approximately 15 centimeter cube of distilled water. Stir to make a solution. You will use portions of FB5 solution for the following test and test in B. To a 1 cm depth of FB5 solution in a test tube and a 1 cm depth of dilute hydrochloric acid, record your observation. Effervescence of gas is evolved. Gas or bubbles of gas is evolved, which turns lime water milky. When this effervescence of gas pass through lime water, it turns milky. It means this FB5 contain carbonate ions. It means that FB5 is the ammonium carbonate. Now question number B, part 1. FB6 and FB7 are solutions, each containing one cation and one anion, all of which are listed in the qualitative analysis notes. Carry out the following test in separate test tubes. Choose a 1 cm depth of each solution unless otherwise specified. Add a few drops of barium chloride to FB5. White precipitates are formed. FB6 green precipitates and FB7 colorless solution with little bubbles of gas. Effervescence FB5 when we add in FB6, effervescence of gas, green precipitates. So when FB5 added in FB7, effervescence of gas evolves and colorless solution is formed. Add few drops of aqueous sodium hydroxide plus aluminum foil and heat. We know that this is the test of nitrate ion from the table given below. This is the test of nitrate ions. Ammonia gas evolved which turns damp red litmus paper blue. It means it means that FB7 contain nitrate ion as well. And if effervescence of gas evolves to form colorless solution, it means this contain acid and FB7 contain H positive ion as well. So carry out tests using aqueous sodium hydroxide and dilute ammonia to confirm the identify of the ions in FB6. Record your tests and observations in the table in the space below. FB6, when we add sodium hydroxide few drops and then excess green precipitates are formed, and in excess sodium hydroxide green precipitate dissolves to form green solution. And when we add ammonia solution in a separate test tube, green precipitates are formed which remain insoluble with excess of ammonia solution. It means FB6 contain chromium ion. Part C, FB8 contain one anion and one cation, both of which are listed in the qualitative analysis notes. Heat a small spatula, measure FB8 strongly in a hard glass test tube. Allow the test tube and contents to cool. Record all your observations. Effervescence of gas, white solid turns yellow, water vapors on the walls of the test tube. On cooling, yellow solid turns white, and it means effervescence of gas which white solid turns yellow, water vapors on the walls of the test tubes, and on cooling yellow solid turns white. Okay. Add a small spatula, measure to 3 cm depth of dilute sulfuric acid in test tube. Record all your observation. Effervescence of gas which turns lime water milky, that is, it means carbon dioxide is present, and if carbon dioxide is present, that FB8 contain carbonate ion. White solid dissolves to form colorless solution. If necessary, pour off the solution obtained in A2 in order to separate it from any remaining solid. Divide the solution into 2 equal portions in boiling tubes. Carry out the following test and record your observations. To the first boiling tube, add aqueous sodium hydroxide. White precipitates appeared which dissolved in excess of sodium hydroxide to form colorless solution. To the second boiling tube, add aqueous ammonia. White precipitates appeared which dissolved to form colorless solution. It means if white precipitate formed and dissolves in excess of sodium hydroxide, it means might be zinc ion, aluminum ion may be present in this FB8. To the second boiling tube and add aqueous ammonia. White precipitate appeared which dissolved to form colorless solution. It means if white precipitate dissolves to form colorless solution, then it must be zinc ions. Suggest the identity of FB2. So negative ions confirmed this test because carbon dioxide effervescence formed which turns lime water milky. It means if carbon dioxide is evolved and turns lime water milky, that is carbonate ions, and sodium hydroxide and aqueous ammonia test confirm the zinc ion present in this solution. So suggest the identity of FB8 is the zinc carbonate. FB9 is aqueous solution of covalently bonded compounds. Heat half fill the beaker with water and place it on a tripod and gauze. Heat until the water begins to boil and then turn off the Bunsen burner. This will be used as a hot water bath. Complete the table by carrying out the test described. Use a 1 cm depth of FB9 in a test tube for each test. Test 1, add an aqueous equal volume of dilute sulfuric acid and a few drops of aqueous acidified potassium manganate. Then solution turned from purple to pink. When we add potassium manganate turns from purple to pink, and when I place this in hot water bath, solution turns colorless. Test 2, add an aqueous equal volume of aqueous iodine, then add aqueous sodium hydroxide. This is triiodoform test. Aqueous sodium hydroxide until no further change occurs. Leave the tube to stand. So yellow precipitate is formed, which confirms that this is ethanol, because ethanol gives the yellow precipitate with the triiodoform test. FB9 contains an organic compound. From your observation, suggest one possible identity for this compound. Explain your answer. In this compound confirm. Add an equal this test confirms the alcohol, because when we add an equal volume of dilute sulfuric acid and then few drops of aqueous potassium manganate, so alcohol is oxidized to form carboxylic acid. So this FB9 is solution. FB9 is alcohol, because when we add few drops of acid along with acidified potassium manganate, so it oxidizes ethanol to ethanoic acid. So place in the hot water bath, so solution turns colorless, because on heating it gives purple to colorless. So over here purple to pink, and when we placed it in hot water bath, it turns colorless. So test 2 confirms that this is ethanol, because this triiodoform test only gives positive test if CH3 is bonded with carbon atom which is directly attached with alcohol. So this gives positive test of triiodine. So test 2 confirmed that this is ethanol. So test 2 confirmed ethanol, because yellow precipitate of CHI3 is formed. Hopefully you understood this qualitative analysis question. If you understood, please like the video and subscribe the channel. Thank you.